So here, find the cosine half range series of f of x. That f of x is nothing but x into sine of x, that is in the range 0 to pi, and we have to deduce this thing. So here, or else this one, both one at the same only. Okay, so what we will do is that f of x equal to x into sine x. uh, it is defined over 0 to pi. So length of the interval is with respect to half range, b minus e. So that is b is here pi, a is 0, pi minus 0 is pi. So length of the interval is pi. Half range Fourier series, cosine series. What is cosine series is f of x is equal to a naught by 2 plus summation of an into cos n pi x divided by L, but L is pi here. So this pi get cancels. So I am getting, that is f of x is equal to a naught by 2 plus summation of an cos of nx, n is from 1 to infinity because pi get cancels. So next thing is that, so a naught is as usual. So what is the formula for a naught? 2 by L a to a plus 2L f of x dx. So 2 by L is pi here, and what is total length of the interval? That is 0 to pi. F of x is x into sine x dx. So liate. So algebraic term, trigonometric term. So therefore what we will do is that, hello, any doubts? Sujit? Hello? So 2 by pi, hello? Rishikesh? Rishikesh? Huh, any doubts? Huh? So,
Yes, sir.
hi, any doubts?
No, sir.
Okay, fine. So, this x into sin x is there, no? So, I'll apply the Bernoulli's rule. First function into integration of the second minus differentiation of x is 1. Double integration of sine of x dx into dx, again plus differentiation of this 1 is 0. 0 into anything is 0. Next term onwards it is 0 only. So therefore what we will do is that 2 by pi x into integration of sin x is minus cos x minus double integration of sin x is minus sin x over 0 to pi. So when you simplify this, minus x cos x minus minus plus sin x between 0 to pi. So upper integral is minus pi cos of pi plus sin of pi minus 0 into cos of 0, that is 0, plus sin of 0 is 0. So second term reduces to 0. So minus pi cos of pi is minus 1, sin of pi is 0. So 2 by pi minus pi into minus 1, minus minus plus 2 pi divided by pi get cancels. So a naught is 2. So this is how we will get it. Next, En is equal to same 2 by L a to a plus 2L f of x cos n pi x divided by L. L is pi get cancels. So 2 by pi, so x into sin x, sin x into cos of nx dx. So we know that sin A cos B formula, that is half sin A plus B minus sin of A minus B. So we here instead of A x is there, instead of B nx is there. Half sin of x plus nx minus sin of x minus nx. So half sin of n plus 1, x is common, minus sin of 1 minus n x. So sin of n plus 1 minus, so 1 minus n, I'll make it as n minus 1 to have the common format. So sin of minus of n minus 1 into x. So sin of n plus 1 into x as it is here. Okay, sine of minus theta is minus theta. This minus theta is minus. So plus sine of n minus 1 into x. So this result is true when n is not equal to 1. If n is equal to 1, it reduces to 0. So what I will do, this is I am proving n is not equal to 1. So 2 by pi, 0 to pi x. So this same thing you can see here, this one I'll substitute here, 2 by pi, 0 to pi x as it is. This means this, that I am writing half sine of n plus 1 into x plus sine of n minus 1 into x dx. So next thing is that, therefore 2 by pi, that 1 by 2 also I am taking out. So x, I'll multiply inside, x into sine of n plus 1, sine of n plus 1 into x plus x into sine of n minus 1 into x. So as in between plus sign is there, I'll separate the integration sign. So these two get cancels. 1 by pi, 0 to pi x into sine of n plus 1 dx. Next integration is 0 to pi x into sine of n minus 1 into x dx. So you expand this also, you expand this also. So 1 by pi, apply the Bernoulli's rule for this as well as for this. So therefore what we will do is that x into integration of sine of n plus 1 into x dx minus differentiation of x is 1. Next, double integration of sine of n plus 1 into x dx. Next, later it will come 0 because differentiation of 1 is 0. Next, I'll integrate this x into sine of n minus 1 into x dx. Differentiation of x is 1. Double integration of sine of n minus 1 into dx between 0 to pi. So 1 by pi, I'll simplify clearly everything. So this is minus y minus sine differentiation is minus cos. So minus x into cos of n plus 1 into x divided by n plus 1 minus, so double integration of this sine is minus sine of n plus 1 x divided by n plus 1 the square. Similarly, this integration and this integration will be these two. So next, I'll take it in one bracket only. So next, therefore 1 by pi minus x into cos of n plus 1 into x divided by n plus 1 minus plus sin n plus 1 x divided by n plus 1 the square, which is integrate between 0 to pi. Next one is minus x cos of n minus 1 into x divided by n minus 1 minus plus sin of n minus 1 into x divided by n minus 1 the square, which is from 0 to pi. So 1 upon pi, so please, so 0 to pi is there, no? So substitute, what is that? Upper integral is pi. First substitute pi. So minus pi cos of n plus 1 into pi divided by n plus 1 sin of n plus 1 into pi, that is 0. Next substitute 0. 0 into anything is 0. Sin of 0 is 0. Means this term reduces to 0. Similarly, again substitute pi here. So minus pi cos of n minus 1 into pi divided by n minus 1 plus sin of n minus 1 into pi divided by n minus 1 the square is 0. Next 0, this is 0 and this is 0. 0 plus 0. So what we are getting is that minus pi divided by n plus 1. We know that cos n pi can be written as minus 1 raised to n. Cos of n plus 1 into pi can be written as minus 1 raised to n plus 1. So similarly, cos of n minus 1 into pi is minus 1 raised to n minus 1. So therefore, minus pi, this everything is completed. So I'll split this function. I'll split it this minus 1 raised to n minus 1 raised to n minus 1 raised to n minus 1 raised to minus 1. Minus 1 raised to minus 1 is 1 upon minus 1. So 1 upon minus 1 is minus 1. So I had written directly here minus 1 minus 1 raised to n minus 1 raised to 1 minus 1 minus 1 raised to n minus 1 raised to minus 1. So here pi get cancels. So here this minus plus minus 1 raised to n as it is. So here minus plus this minus as it is, minus 1 raised to n divided by n minus 1. So n plus 1 n minus 1 will be the LCM. So n minus 1 into minus 1 raised to n minus n plus 1 into minus 1 raised to n. So here minus 1 raised to n is a common quantity. So take out n minus 1 minus n plus 1 divided by n square minus 1 square. So open the bracket, n get cancels, minus 1 minus 2 minus 1 raised to n. So 2 into, see this is minus 1 and one more is minus 1 raised to n. So whenever bases are same we can add the powers. So here power is 1, here is n. So what I will do is that minus 1 raised to n plus 1 divided by n square minus 1, where n is not equal to 1. If n is equal to 1, that also we have to try it here. So whenever n equal to 1, equation 2 becomes 2 by pi 0 to pi x into sin x, cos nx is there, but n is equal to 1 I am taking. So it becomes cos of x dx. So we know that this 2 I will take inside. So 2 sin x into cos x, sin of 2x. So this formula you can see, okay, sin of 2x. So x into integration of sin 2x minus double integration of sin 2x dx, because the differentiation of x is 1 here, which is integrated between 0 to pi. So a1 is equal to 1 upon pi x into minus cos of 2x divided by 2 minus sin 2x divided by 4, which is from 0 to pi. So substitute upper integral as well as lower integral. So 1 upon pi minus x cos 2x divided by 2 minus plus sin 2x divided by 4. So substitute upper integral, minus pi cos 2 pi divided by 2 plus sin 2 pi divided by 2 minus, this is also 0, this is also 0, when you substitute 0, x equal to 0. So what we are getting, minus pi cos of 2 pi, that is cos of 0, 1, sin 2 pi is 0. So what I am getting, minus pi into 1 is minus pi by 2, this is 1 by pi get cancels, minus 1 by 2. So a1 is equal to minus 1 by 2. So therefore f of x is a naught by 2, a naught is 2. So a1 cos x plus a2 cos 2x plus a3 cos of 3x. So expand equation number 1. So f of x equal to 2 get cancels, it is 1. So a1 means what, just now I got it. So that value substitute minus 1 by 2. So you can see here a1 is minus 1 by 2. So next plus, so from this onwards you write summation of a n cos of nx. N is ranging from 2 to infinity. This is important. Earlier n is ranging from 1 to infinity. That one term I have taken here. So next time I am writing it as 2 to infinity. So 1 minus 1 by 2 cos of x plus a n means what? Already I have got it. 2 minus 1 raised to n plus 1 divided by n square minus 1 into cos of nx. So 1 minus 1 by 2 cos x. So 2 you take out. So n is 2 to infinity minus 1 raised to n plus 1 divided by n square minus 1 into cos of nx. So put x equal to pi by 2 so that the term will not vanish. So f of x is x into sin x, f of pi by 2 into sin pi by 2. So f of pi by 2 is pi by 2 into sin pi by 2 is 1. F of pi by 2 is equal to 5 by 2. So f of pi by 2, 1 minus 1 by 2 cos pi by 2, because x equal to pi by 2 I am taking. So 2 into summation minus 1 raised to n divided by n square minus 1 cos of n into x, x is pi by 2, it is n pi by 2. So next, so everyone you can see here, f of pi by 2, f of pi by 2, what is this? Pi by 2. 1 minus 1 by 2 cos pi by 2 is 0. So here you allow n is equal to 1, 2, sorry, not 1, 2, 3, 4 and so on. N is equal to 2 this term, n is equal to 3 this term, n is equal to 4 this term, n is equal to 5, n is equal to 6, n is equal to 7, so on, so forth. Okay. So next thing is that pi by 2, 1 plus. So this is 0. So here for cos 3 pi by 2, see what exactly cos pi by 2, 3 pi by 2 in the sense cos of 0 is 1, cos of pi is minus 1. Cos pi by 2 is 1, cos 3 pi by 2 is, sorry, cos pi by 2 is 0, cos 3 pi by 2 is 0. Okay. Similarly 5 pi by 2 is 0. So all odd terms gets 0. So only this much is remained. So cos pi get cancels. Cos of pi is minus 1. 2 pi. Cos of 2 pi is plus 1. That's what I wrote it here. Okay. So minus minus plus 1 by 3 plus minus minus 1 upon 15. So this pi by 2, this term I'll shift it to this side, minus 1, 2 into it becomes this. So pi minus 2 divided by 2, this 2 also I'll shift it to this side. So pi minus 2 divided by 2 into t, 1 by 3 minus 1 by 15. So next thing is that 5 minus 2 divided by 4. So that 1 by 3 I can write 1 upon 1 into 3 because I have to write it in the standard form. 15 I can write it at 1 upon 3 to 15, so on so forth. Okay. So next you can see next question. Obtain sine half range series of f of x is equal to 1 by 4 minus x in 0 less than x less than 1 by 2. Next, x minus 3 by 4 in 1 by 2 less than x less than 1. So, f of x is total interval is what? 0 to 1. F of x is defined in 0 to 1. Therefore, length of the interval is b minus a, 1 minus 0, that is 1. Sine half range series is f of x is equal to sine series we are writing here, half range sine series, that is bn into sine n pi x divided by L. L is 1, so it is becoming bn into sine of n pi x. So bn is equal to 2 by 1 summation 0 to 1 f of x. So this example, L is equal to 1 means it is sine of n pi x. So therefore 2 by bn I'll take 2 by L. L is 1 here. 0 to 1 f of x sine n pi x divided by L. L is 1 into dx. So bn is what? 2. 0 to 1 f of x into sine n pi x dx. I cannot substitute f of x here because f of x is splitted one in 0 to 1 by 2, next one is 1 by 2 to 1. So 2 into 0 to 1 by 2, f of x is 1 by 4 minus x, that I substituted sine n pi x dx plus 1 by 2 to 1. Okay. So f of x is x minus 3 by 4 sine n pi x dx. So next thing is that 1 by 4 minus x. So just integration by parts. 1 by 4 minus x integration of sine n pi x dx minus differentiation of this. Differentiation of 4 is 0, differentiation of x is 1, so minus sign already it is there, double integration of sine n pi x dx. Similarly, x minus 3 by 4 integration of sine n pi x dx, differentiation of x is 1. Okay, differentiation of 3 by 4 is 0, double integration of sine n pi x dx into dx. So next, when you simplify, you are getting like this. Just I'll send the notes, check it. You're getting like this. So next, therefore bn you're getting like this. Once you substitute upper integral, next you substitute lower integral, again for this term substitute upper integral and lower integral. So this is what your exactly simplification is. These are the two terms. Okay, so this is your upper integral minus lower integral. This is upper integral minus lower integral. So if you substitute, so what you are getting is that 1 by 2 minus 1 by 4 is 1 by 4, 1 upon n pi cos n pi by 2 minus 1 upon n square pi square sin n pi by 2. This minus, see here, this minus and minus plus 1 upon 4 n pi. 3 by 4 minus 1 is minus 1 by 4 cos n pi divided, or cos n pi is what? Minus 1 raised to n divided by n of pi, minus 3 by 4 minus 1 by 2 is 1 by 4 1 upon n pi cos n pi by 2. So 1 upon n square pi square, this sine of n pi by 2, sine of n pi by 2. Understood? Hello? 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 Hello?
Hello, sir.
You are getting the things?
Hello.
You are getting the things, huh?
Yes, sir.
Okay, fine. So when you simplify this, 2 into 1 upon 4 n pi cos n pi by 2 minus 1 upon n square pi square sin n pi by 2 plus 1 upon 4 n pi minus 1 upon 4 n pi minus 1 raised to n minus 1 upon 4 n pi cos n pi by 2 minus 1 upon n square pi square sin n pi by 2. See, plus 1 upon 4 n pi, 1 second, 1 upon 4 n pi by 2 minus 1 upon 4 n pi by 2 cos n pi by 2 cos n pi by 2 get cancels. So what is remained? This is minus 1 minus 1, that is minus 2 divided by n square. See, both the terms are same. So minus 2 divided by n square pi square sin n pi by 2 plus 1 upon 4 n pi. So here between these two you can see what is common. 1 upon 4 n pi is common, 1 minus minus 1 raised to n. So that 2 we will allow inside now. So that is 2 to the minus 4 divided by n square pi square sin n pi by 2 plus 2 divided by 4 n pi 1 minus minus 1 raised to n. So bn is equal to minus 4 divided by n square pi square sin n pi by 2. 2 ones are 2 twos are. So that is 1 upon 2 n pi 1 minus minus 1 raised to n. So therefore this is what your bn is. This is what your bn is. So equation 1 becomes f of x is equal to minus 4 divided by n square pi square sin n pi by 2 1 upon 2 n pi 1 minus minus 1 raised to n sin of n pi x. This I have substituted in equation 1. So this is half range sine series. This is half range sine series. So any doubts? Okay, fine. So next we will see the practical harmonic analysis. Next concept it is. So here I took the things directly. A naught by 2 is called as a constant term. A1 cos x plus B1 sin x is first harmonic. A2 cos 2x, B2 sin 2x is called second harmonic. Okay, suppose if the interval is 2 pi, so you use these formulas. That is A naught equal to 2 by capital N summation of y. An is 2 by capital N summation of y into cos of nx. Bn is 2 by capital N summation of y into sin of nx. If length of the interval is 2l, so you can use Al is equal to 2 by capital N summation of y into cos n pi x divided by L. Bn is equal to 2 by capital N into summation of y into sin n pi x divided by L. So next thing is that hello.